Okay, let us now to consider the concept of urban platform. What can be used as a urban platform? So we have seen the example of Florence. There is a strong motivation to start at working in making a smart city. So because there is for the 2050 more than 75% of population are going to live in the city. So this because there is a strong attraction for the city, high salaries, more opportunities. And that city has to cope with the increment of citizens providing a higher quality of service and efficiency. To this end, it is very, very relevant to maintain under control expenses and quality of service, and to create also new services and obtain the sustainability of the present service. Services, the more expensive services as those related to mobility, energy, environmental, etc. So the moves for smart city in general see a lot of services. We have seen a lot of examples for the city in which we have already deployed some of the results. So this is a classical pictures in which you represented the smart city with the smart house, smart mobility, smart energy, and so on. So the process to making smarter a city is not only a process that you can do politically driven or technology driven or organization driven. So all these three parts have to be synergic each other to work together to create a smart city initiative. Most of the city thinks that probably they are the first pusher, but in any way they need to have the service of the technology. They need to have the pushing also of organization that are around there. So this is the mechanism to work together, to don't conflict, to avoid competing, and to spread the effort and cost in the whole network. The idea of Living Lab is coherent with this vision that could really create a smart city initiative exploiting all the aspects. Technology means also to involve the university or to involve the companies that could help the city to be smarter. Policy obviously is the governments of the city, and organization. There are a lot of organization around the city, including research organization or foundation or others organization like that. So the smart city domains are many: health, education, economy, energy, environment, mobility. Most of the most relevant are surely the mobility and transports, the environmental and energy are the most technical and relevant, but also the people in living, the governmental are very important, and the economic aspect and health. So all of them are important, but some of the city have more focus on a few of them, while a balanced view of all these services together, I think, is the best way to move ahead. Sustainability means also to respect the increment of population, so to increase the quality of life anyway, but increase the number of services, to increase the capability to take decisions faster and precise, because when the city is growing, the complex are growing as well. And so you need to really be fast, to really be capable to inform the citizens of what is going to be changes, what is going to be provided in time. And the citizens also have to be formed, not only informed, but they need to have to be trained to use the new technology, to use the new services, to collect from them feedback, to create a continuously feedback from them. And the hub an integrated hub, a multi-channel hub with the possibilities of accessing, providing information on multiple domains through an app that could be also used to collect the feedback from the citizen is probably the best way to do it. Most of the city thinks that they create their own hub could be the best way. Their own hub created self-made hubs, but the real activity is to do it through professional or through really well-stated solution, maybe open source and so on, could be the best way to do it, because otherwise most of the city have tens of hundreds of different apps that covers part of the relationship with the citizen, while the data are of the city, and the city is the only one that could really provide good service for the citizen. So you have the idea of the smart city engine could be something that is in the middle from the several stakeholders that we see on the left side. The stakeholder could produce data and also take back some of the information from the smart city engine. So the stakeholder on the left side could be very proud and very efficient in producing a number of data that could be used for many different purposes, like mobility, traffic, flow, environment, weather, statistics, access, museum, point of interest, and so on. So there are a lot of public data and private data that could be capitalized and to be exploited in the smart city engine, including the profile of the user, because if you have apps and the other things like what you have here on the right side, you can collect from the citizen where they go, what they do, what they prefer, which kind of service are appreciated or not appreciated. So is a real environment in which you can understand which kind of how much time they stay, if they are tourists, where they go when they move in the city, and so on. So if you are capable to extract this information from the apps and maybe stimulating the customers that would like to take the app to also use a city standard for collecting the data, or a city service to send and get back the feedback. This is the role of the smart city engine. The smart city engine could be the place in which you can stimulate your companies that use and could provide data and could exploit the data from the smart city engine to work with you. So to really exchange the data, and you can, in this way, from the smart city engine, collect the user profiling, understand how the city is used, what should be done to improve the service, and maybe rendering outside to small, medium enterprise and others the information that you have, because if you know exactly what is going on, you can market your city, you can describe which are the benefits for a company that could move in the city, or which are the benefit of a company that could be interested to open a new commercial activity in your city. And this is very, very important. So when we developed the Snap4City, it was developed taking into account a number of international collection of requirements. And some of them are listed here. For instance, ENOL, the European Network of Living Lab, has defined a set of requirements. You can find them at that portal address. So another nice collection of requirements for Smart City. The first one was for Living Lab, mainly for Smart City Living Lab. The second one, the APE, the European Innovation Partnership for Smart City and Community, is a community that was set up by the European Commission to follow all the activity of the major project in the Smart City in Europe. And they have also created a number of technical committee, and they have done a very big work in defining requirements. And the last one has been Select4City. It was a project of the European Commission that started as a pre-commercial procurement challenge in which we participated together with other more than 25 different other companies and groups. And groups, with the aim of creating an Internet of Everything smart city platform for Living Lab. Select4City really extracted, taken all the requirements of ANOL and a large number of requirements of APE to define the challenge. We developed the Snap4City taking into account all of those requirements and other requirements that we collected from other sources, and we satisfy all of them. Requirements identified by Select4City was related to the quite detailed level, and they were related to the city dashboard, to the application user interface, to the how to manage the historical data and open data, how to create a data-driven real-time communication and processing, how to manage IoT workflow and IoT application on cloud and on edge, how to exploit microservices, how to manage input and output data-driven flows from in the context of smart city, how to integrate data analytics, exploiting machine learning, statistics, reasoning, and so on, how to serve the city as a living lab for open innovation, for co-working, for collaborative work, for sharing data, process, dashboard experience, and solution. So how to scale up from small cases to large cases, from small city to large city. And a set of non-functional requirements for open source, demanding open source, with the capability to support any open standard, to be scalable, robust, distributed, and modular, and service-oriented, to be totally data-driven for reading reading data and data analytics, to support heterogeneous devices, but also heterogeneous environment in which you have a private and public data, or devices, or dashboard, to be strongly interoperable in terms of protocols, in terms of APIs, in terms of smart city API, to be capable to integrate any legacy conditions in place, to be modular and reusable for the future, to be capable to communicate with any kind of things and protocols and formats, to be secure, to pass penetration test, vulnerability test, to have an end-to-end encryption of in the end-to-end communication and protected communication, starting from the device up to the user interface, to be totally user-centric and respecting privacy by design, support the GDPR, and personalized features and data management. All of these requirements. Private data management, browsing and download is secure enough to delegate management of data of the public security and administration. So this is very important to be safe, to be secure and respecting privacy on all the activity that you do, especially if you would like to integrate the data of your final user with the data of the public administration. And the pre-commercial procurement started in the 2017 and finished in the 2019, in November of the 2019. And over the more than 24 different competing partners, we have been selected to be the winner. There is a web page the portal, in which you can see the list of the competing partners. So, and the award has been provided to us from Digipolis in Antwerp, Forum Viro in Helsinki, and the city of Copenhagen. So, in this context, we think that the smart city should manage a sort of stack in which you have data ingestion, data aggregation, data processing, data rendering, assessment strategy, and decision support system. So for each layer, we need a set of two different tools that could allow you to manage ingestion, aggregation, process rendering, strategy, and decision support. This is a very, very important. For data collection, data in most of the city are private or open. They may arrive with many different kind of GDPR, static or real-time, any protocol, any standard. And so it's very important to exploit all the legacy that you have, external services, microservices, and so on. So the data can be private, public, real-time, or no, private or public, real-time or static. There are many other, let's say, gray level in the middle on which you have to cope with. There is no very drastic difference, and each single data has to be addressed with his own license. These kind of problems are typically big data problem. Even in the city, you may think that the city are going to address only few data, but in reality, if you have a relevant city, a huge volume of data, or even if they don't arrive inside the storage fast as the data in the industry plant, a lot of heterogeneity in the data, a different frequency of arrival of the data is a big problem. So we see inside the city most of the feature of the big data. So the variety, the value, the velocity, the variability, and finally also the volume if the city is relevant. So to produce an urban platform in aggregating the data, making with exploiting this data with maybe with the prediction, with the user behavior analysis, with the possibilities of creating a control room is a way to create value from the data, as I explained before. In this context of data collection, take very relevant the creation of mechanism for data indexing. So to have a possibility, because the data that you collect may be structured and non-structured. So maybe just data coming from sensors or database. But you may also have some post or other text that is written in natural languages, so it's not structured data. You may have spatial data, geographic spatial data. You need to have temporal index because the data, the situation is changing over time. You need to have a semantic index with a lot of relationship among the city entities. And the data type associated to the value can be very different. So in the processing usually there are a lot of solution to make a process. In the context of Snap4City, we started years ago to use the ATL model with the Pentao kettle, and then we recently totally moved on IoT app based on Node-RED. So we are moving in using a Node.js for almost everything, for data ingestion and data transformation. When it's needed, it's possible to make some data analytics with processing with the RStudio or Python or other languages. So another level of very strongly interesting level is the possibilities of providing specific views and graphic views, visual analytics and dashboard that could allow to extract and to render the complexity of the data in a visual manner, easy to address, easy to understand, because when you have critical condition, you don't have time to make reasoning and so on. So you need visual analytics and data analytics, and this has to be prepared offline. So you need some processing to prepare the visualization. For instance, maps or matching or diagrams or heat maps that could allow you to grab to get the hints about what is going on immediately. Up to the visualization, you need also decision support. So some tools for acting or for harming you about what is going on. And this could be based on some analytics again, could be, for instance, based on prediction, simulation, anomaly detection. And typically when you have this kind of algorithm for as a decision support, they manage heterogeneous data, they manage a huge amount of data. You may need to have some what-if analysis. What could be done if we move this bus stop, or what could be done if you close this part of the city, and how the traffic could pass, how many traffic is going to take that path with respect to the others, to the present situation. What is going to happen if I add one more bus line passing through a bus stop? Or why in this moment I have too many people at the bus stop and I need to reschedule or to rethink a bit my plan in the city to reduce the number, the typical amount of people for each bus stops that may raise problems. We have seen now a lot of criticality about the social interaction that you may have in the city. So if you may analyze the city and may analyze the service to identify which service should be rescheduled or should be replanned to have a less crowded condition, could reduce the impact and the social spreading of virus or others. So this means that in the strategy we described before, there are a lot of red arrows that are going to bring back to the stakeholder, to the operators, and to the users information. This information could be used for suggesting path and behavior to the final user, just to have a risk map, for instance, for moving, or to have the heat map for risk, for virus, or the risk for pollutant, or the risk for getting trapped in the traffic. This could be the information that the user could be interested to have. But the same information could be very useful for the stakeholder, and the same information could be very useful for the operators. So to see in advance what is going to happen. So to be informed, to be suggested, to be engaged, to be early warning, to get some early warning about what could happen. And so this could be the way to take the right decision on the basis of data and not on the basis of hypotheses that are not supported by data. The concept of living lab that I mentioned before also include the possibilities to perform the activity we mentioned here for aggregating, exploiting, and suggesting, and providing support in terms of the decision maker. it's also very important to provide multiple modality to perform the same activity, because you have legacy system, you need to pass with the data from one way and another, because you have different kind of operators and city users in general, and because you have many different kind of situation in which you need to use different kind of tools. So these slides have been already presented, so you know the mechanism for activating the Living Lab. I am not going to replicate again, but just to remind you that the tools and the portal is defined, is implemented in a way to provide at the developer all the information they need. So what has been published, what the exercise that they could be interested to do, the search tool in which they can put queries to search for information, and the exercise to perform experiments and understand how it works. On the left side, the large menu that can depend on the role. So if higher role means larger functionality, and up to the root tool administrator as me, that could allow you to understand all what is going on, what has been done, what is auditing and managing users and assessment, security, continuous monitoring, what is going on. So you can also deploy, use Snap4City as a service from cloud, or deploy on your premise, as mentioned before. Everything is enforced in terms of development life cycle. We have already mentioned it before, so I am skipping. You need some references. There are hundreds of test cases inside that can be used for you to understand how it's work. We go more in deep in the city architecture. We have already discussed before the smart city architecture. What is unique with respect to the other architecture? We think that we have this unified data model in which all the data are aggregated. We have a semantic reasoner for integrating all the information and making this sort of expert system with the data of the city. There are a number of tools that allow you to integrate the data, such as the IoT directory abstraction, on which you can connect any kind of brokers and devices, IoT device, IoT edge device, IoT brokers, different protocols, different formats. You may enforce data analytics and data process into the IoT application. You can use multiple programming language. You can add the visual analytics on dashboard, and there is a tool that is called the Wizard, which is another expert system to create a dashboard for you by using a few number of clicks. So you just click the variables, the data you are interested, and the suggestion of which kind of visualization they could be associated with in your dashboard will appear. So you can just in few clicks create your dashboard. And mobile app and strategy. From the non-functional aspect, the Snap4City is unique because support Living Lab for co-working, sharing, and delegation is a multi-tenancy application that you can install as a multi-tenancy in your premise. So it means that you can even become a manager of multiple cities with one single installation of Snap4City on your premise, on your cloud, on your servers. It is 100% open source and also support hardware and software for devices, guarantee hand-to-hand encrypted communication. It is GDPR compliant. It passed the penetration test from SETEC and vulnerability test from Thales. You can use on-premise, on functional. it is provided as a virtual machine, and containers is flexible, modular, and also, let's say, scalable. This is the picture that we already presented before. I am not going to redescribe again, but it's a reference. So it's very important that what you have on the right side are the dashboard and the front end, and what is in the back are a lot of tools that allow you to monitor what is going on. The portal is the main entrance, and I think that we can go ahead talking about dashboard, from city dashboard to application, how to pass from city dashboard to application. So when you enter in the portal, you have the possibilities to access, even if you are not registered, you can access to a number of public dashboard. They are examples, some of them are real dashboard of municipality that they decided to make them public. They are not the only dashboard that are being created with the Snap4City. Those are only the public dashboard, because some of the city, depending on the data they have, decided to maintain their dashboard private, because maybe there are data that are sensitive and will not be very easily communicated, are technical aspects that could not be communicated, would not be nice to be communicated with the city users. This is an example with a measure of Florence, Dario Nardella, his control room dashboard. We already mentioned that most of these dashboards are connected at the second level with the other dashboard. We already described this what-if analysis dashboard. Behind this business analysis, this what-if analysis dashboard, there are others dashboard. For instance, for the traffic flow monitoring, you see this was a Saturday. So Saturday, you see the difference for Saturday and Friday. This is just recent. So you see the COVID effect of reduction of traffic flow in Florence that has been reduced of 1/5, or reduced to 20%, let's say. Is quite evident, and so you can monitor all the inflow total of the day. Usually we are close to the 296,000 cars entering or exiting from the city, and is now is much lower, as you see here. Okay,